Okay, so the schedule for the class has finally got us up to graphical user interfaces. Personally, I would have started with this. The problem with that is that I need to be consistent with all the other versions of this course running at Ivy Tech, which bring it in later. But we're finally up to it. And one thing that I wanted to start with here is I have never found a textbook that I am happy with the introduction to graphical user interfaces. And it's not just textbooks. A lot of the online tutorials, most of the online tutorials, I kind of feel the same way about. I don't feel that the way they're introduced is acceptable. Obviously, some of what I'm getting ready to say is, not going to happen the first day, but I want to start with kind of the idea of what the goal should be in. And I don't mean just a little unhappy with how the textbooks present it. For example, in our textbook for this class, when they were doing the section on reading files, the condition in all the examples just said, while it's not a blank line. And then when it hits a blank line, then it's done reading the file. Which, when I read that, I immediately thought, well, there's much better things to check than that, because there might be blank lines in files, right? If we have a bunch of stuff in the list and work with it, and one of those items gets deleted, but that spot doesn't get removed, then we write that list to a file, there's going to be a blank line right in the middle of the file. So that condition would only read up to that blank line. So there's much better things to check, but that's not that big of a deal. In most cases, if it's a file that we wrote, there's probably not going to be blank lines. That's okay thing to check, but I feel like there might be better. That's how I usually feel about the stuff in the textbooks, or sometimes I see things that I think would be things, I do things a different way that I think are easier, little things like that. But with graphical user interfaces, when I read those sections in textbooks, it's pushing on making me mad. I do not like the way textbooks present it, and I have never found one that I'm even remotely happy with. So there's some syntax stuff in our textbooks that still applies, but there's some kind of the problem has to do with what these should look like. I'm going to open Notepad++ to start with here, just kind of our basic one. I guess what happens in the textbooks, I would barely even count acceptable for a dialog box. Like here, if we go to the converter box, something like this, enter some number, get all the conversion factors for it. But the little pop-up dialog boxes, I wouldn't even consider most of what I've seen in textbooks acceptable for this. There's no spacing, no layout, no real good layout to them. Things are just kind of randomly thrown in there. There's only one way to do stuff. I'm just very, very disappointed with what I've always seen in textbooks and tutorials about this. Again, we're not going to get to this point on day one, but I wanted to start here with just keeping in mind where we should be working towards with graphical user interfaces, or GUIs. It's kind of a standard appearance, right? This is the older style. There's some new ones, but a main menu up top, followed by a toolbar. Then we have a section with our main content, maybe 2 or 3 windows or more scattered around with the main content. Then at the bottom, some sort of status bar. And there's updated versions as well. I have Word open here. They've kind of combined that top level menu and the toolbar into one thing that we usually refer to as a ribbon to organize things. That's the combination of them. Or here, that's too big. Open Google Jamboard. Another modern look is to use the hamburger buttons, these things with 3 lines, usually call those hamburger buttons, and then put the put the menu vertically instead of horizontally. So just some updated appearances, but the layout, if you can do this layout, you can do those updated layouts just as well. So I was going to kind of look at a traditional one. The main menu up top, the toolbar, our main content, which some things obviously are going to have several windows there instead of just one, and a status bar at the bottom saying what's going on with it. And the thing about that is when a user opens this stuff, they know what to do with it, right? Y'all have probably been there before. You download some software that you've never used before and have no idea, don't really have any idea where to start, but then again, you do. You probably know that if you come over to the File menu, the first button you get to is going to be New. So if you click that, that's going to get you started in whatever the software is, right? That near standardization, the things we can always look for. There's another instructor here at Ivy Tech in the IT department. I don't want to mention names on the public video here, but he told a story about being, I believe it was in China, somewhere in Asia. He was in China or something, and he needed to do some work. So there at his hotel, he got on the computer and tried to open some software to do his work, and everything was in Chinese, and he couldn't read Chinese, so he couldn't read what any of the menu buttons were saying. Well, couldn't really do anything. But because of that standard layout, he knew exactly where to go in order to set up the language the software was using. So he went to that spot, and I can't recall which one software he said it was, but when he went to the spot where he knew the change language button was, he saw an American flag and was able to do that just because of that standard layout. So keep things like that in mind. You want to give your users software they know how to work with. So we're going to, once you can lay out the traditional one here, I'm going to refer to it that way. It shouldn't be any trouble to change the layout to like the updated combined top level menu and toolbar into the ribbon, or even easier really to just combine to hide it all under a hamburger button and line it up vertically rather than horizontally. So those should be easy transitions. But I just kind of wanted to express this point to start with. So obviously we're not going to be there on day one, but the first thing we're going to look at here is very related to that and kind of getting moving in that direction. So let's get over to that. One quick last point I forgot to mention about that standardization, which you're probably familiar with, is lots of ways to do things. Like I pointed at the New File button, so we can go to File, New, get a new file. Or here in the toolbar, you can click the New button, get a new file. Or we can right-click, get the context menu. I thought there was a place I could right-click and get a new file. I don't see a new. I thought there was a right click to get a new file as well. Control N? Yeah, Control N, open a new file, but lots and lots of ways to do that same thing. And those are events, right? Clicking a mouse, the user can do that. Clicking a mouse here, or clicking a mouse here, or pushing Control N, or right clicking. Those are events that can happen. That's the content for today. This thing about GUIs. And just a quick note, it's not like they wrote, how many did I show? 1, 2, well, 3, 4, however many different ways there are to start a new file. They didn't write a bunch of different methods to create a new file. They only wrote one method to create a new file, and then there's a whole lot of different events that call that same method. So event-driven programming is going to be the main thing content-wise to look at GUIs. Then we'll look at some syntax to get started on, like I was saying, the general standardization. And I want to start with kind of a look at that basic components, which is going to seem overwhelming, but the file's already written. I'm going to send you the files. Obviously, I don't expect you to be able to duplicate that right off the bat, but I do expect you to look through them and try to make sense of it, and hopefully what I'm talking about there makes sense, that when we create software for a user, we want it to look a certain way. We want the user to already know how to get started, right? We want the user to know where they go to click new file and get started. That sort of standardization to appearance on GUIs. So I have a little hello world version, basically what I consider essential for a GUI. So like hello GUI world. So in Python. So let's look at that real quick. So when I send the files out with these videos, when I post the files, there's going to be, these two files will be included. Well, I'll mention this. This is, when I include this, this is kind of become the standard reference for tkinter, the thorough one. Somebody who was unhappy with the way textbooks were presenting it wrote out that. I put it on IvyLearn. I'll probably don't need to send a copy here. It's on IvyLearn, but I might leave it in the folder. He wrote it for his class, and it very quickly became the standard for reference for tkinter, which is TK interface package. That's what we'll be looking at here. TK is one of the originals. It's one of the original GUIs, so some of the stuff in TK might look a little out of date, like it belonged back in the 90s. There's an updated version, TTK, which is also mentioned in here, which by default looks a little better. And the big benefit of that is you'll essentially use CSS to style it. That's in this reference whenever you're ready for that. Again, I was just providing that so you can have that. Some of the ways he notates things might seem confusing at first. I know when I read it, a couple of them were confusing, but it wasn't long before I got used to his notation, and it's consistent throughout. So after you look at it a few times, you maybe double check things on, look at what he did, double check things online, figure out his notation, then that's a lot easier to read. I know it took me a minute to get used to his notation. But in there's going to be this folder with the files called Standard Appearance GUI. And there's two .py files here. I'll go ahead and open both of them. They do exactly the same thing. If I run this one, that's somewhere where I can still grab it. Come over here, run this one. They are exactly the same thing. They do exactly the same thing. The difference is, I can't remember which one I opened first. One of them is object-oriented and the other one is procedure-oriented. So the code is written differently. But otherwise, they do the exact same thing. And from what we've seen in class, we did do one thing on the one lecture on object-oriented stuff, but only one lecture. So one reason for including both is so that you can compare the way things, compare the way it looks procedurally to object-oriented. One of the big differences, the methods are at the bottom in object-oriented, then all the syntax for that, whereas the methods are at the top in the procedure one. From what we've seen, I'm going to go through the procedure one real quick here. And yeah, this is going to be kind of complicated, especially for the first day, but I'm providing this for you to look at for your own reference along the way. You can see it's filled with comments. as I scroll down, it kind of looks like there's more red there than black. So lots and lots of comments describing what's going on, but we're going to kind of walk through it here. I'll run that real quick. It's basically a hello world. We're just saying, wrote this method called say hi, which basically what the method does is it gets the username. So we ask the user for their name, they'll type it in the box here. If it's blank, well, we throw in a default username and then put up a message. And one thing to note here is we looked at lists, and I kind of mentioned this in that lecture. Notice how that list is indexed. It's indexed by a word rather than a number. That's called an associative array. They're a whole lot easier to work with, but all of our TK interface package widgets, we can access properties like the text that the status label, these are both labels, so like the text that label is showing can be accessed with an associative array. So all of our widgets in the package can be accessed via an associative array, which is a whole lot easier to work with than the numerical indexes. But basically just one method that's just kind of like a hello world. So, and then I put in a bunch of ways to do it, and the general look, that general appearance. So this is kind of what I consider essential. Only one button in each one. But in later classes, for like final projects and the SDEV 200 or higher class, I would ask that you do this appearance for the final project, because I feel very strongly that that's what a graphical user interface should look like. And I made the point earlier about spacing and things. I kind of left that out. I just did the minimum here. But I'll start up here with the file menu. The option in the file menu says say hi. So it fills out that little hello message with the default one. And then I can enter a name here. I'll put my name. And then the toolbar button kind of does the same thing. You can see that message change from, well, hello there, user, to, well, hello there, Chris. What's another? Putting human. Then the button down here nested in the main content section. I click that. It calls that same method. Puts up the message. What's something else? Meat bag. Remember Futurama, Bender always called humans that. Which one have I not done yet? Oh, right click. When I right click, I get a little context menu. That's the name of these, the right click ones. We usually say right click menu. The technical term is context menu. But again, it has that message pull up. One more to check. Mostly water. I can't remember what that's from. Some science fiction thing at some point. I remember the aliens kept calling the humans mostly water. And for this, I will push Control Shift H. So a keyboard shortcut, and a bunch of different ways to call that same method. And like I put in the name, this is what I would consider as the minimum essential things for GUI. Our top level menu, which we could put on a hamburger button down the side, lining things up horizontally, vertically, not really that different. A toolbar, which again we could throw in some tab panes and combine the top level menu and the toolbar into one and get a ribbon. Not that much different. But I'm going to start here in the main content, and then a status bar that updates to say what's going on. Sort of the minimum amount. So as we look through here, so the method should look familiar. There's comments everywhere. This one, when we do a key press, it passes in more information. It passes things like which key we pressed and things. So this method just takes in a key press and strips out all that extra information to call our primary method. This one, you basically be able to copy and paste this is boilerplate code to bring up the context menu. The only difference is you customize a different context menu. That's a reference not built in. TK pop-up is the built-in part. But other than that name there, you could just, well, if you called yours context menu, you copy and paste that as boilerplate code for right click. Then we'll see this. So that's how we start our GUI. Then we have put in the title. Oh, that's something else. By default, that's another one a little subtlety that kind of bothers me is the icons. There should be a custom icon, and that custom icon should match the little thing that shows up down in the taskbar or the icon. And that's a subtle thing that I always feel like users are going to notice the icon being missing. So we go back in here, so set that up. Here's the command for putting an icon. This is a geometry object that's kind of standard across platforms and languages, that we get a string that has X and Y dimensions. And they're called geometry objects, kind of standard across languages and running on different platforms. So whether you're in Python on a Windows, Java on a, well, Java's going to be the same anywhere. Python on Windows, Scheme on a Mac, whatever language, something on Linux, whatever language you're working in, that's a consistent one to set up the geometry. I put in the note here, there's easy ways to just ask the operating system for that number. I thought I'd just type it in here though. Then the code for a top level menu. One thing I wanted to point out is Lambda. That's not mentioned in our textbook. So Lambdas go back all the way to the 50s, some of the early programming languages, and it's kind of grown from there. But basically it means wait. So when we call these methods, we could leave out the command equals, say, hi, and then not put parentheses on it. But if we need to pass in an argument to fill a parameter in the method, it will try to do that as soon as it loads. So the Lambda is just saying wait. Wait for the event. So it's a one that's going to show up in a few programming languages. We call them Lambdas, and that just means wait for an event. And it's necessary to pass arguments into a method. But I kind of like y'all saw me do with the global keyword. I go ahead and do it every time. That way I don't have to stop and think about whether I need it or update later and forget to put it or something. So here's where I make that context menu. This is what bindings look like. That's not covered in our textbook. So whatever thing we want to bind to, .bind. Then they look like this. So in a string with angle brackets and the method we're going to call. I did not put a Lambda in here because, yeah, I guess I just forgot. But that's what bindings look like. And then we set up a toolbar, bring in an image for the button, subsamples changes the size. Just kind of quickly going over this. There's lots of comments in there, a lot of repetitive stuff. Then our book only shows the pack method. So what I did is I set up like 3 different frames here. One for the toolbar, one for the main content, and one for the status bar. Then I packed those in, but inside of each one, so like in the toolbar, inside the toolbar I put a grid. Or inside the main content, I set it up as a grid. And so it packs top to bottom, but inside each one of those frames is sort of a grid to lay things out. That's how I usually do those. And then here's a key binding. Kind of looks the same. So .bind to the GUI overall. Could push key press H, and that's listening for press H event. But I went ahead and added Control and Shift for the example, and then it just calls that event. Here's a lambda where we're passing parameters, passing arguments through our lambda event. So we're going to wait to pass this event. Wait to pass this argument is what that's saying. And then main loop is what starts it. So we're going to look at a bunch easier examples through these lectures. I just wanted to kind of cover that basic, I'm going to call it Hello GUI world, the essential. This is what I think is the absolute minimum that should be in a GUI. Top level menu, toolbar, or we could do the modern looks, the main content, and a status bar. And also, I put a note here. I use the old one, those that even predates TK interfaces package is one of the originals. There's an updated TTK, which looks better. So let's get into event-driven programming, and then look at some simpler examples in this, but it's included for you to look at. Okay, so we're up to event-driven programming now. And there's not a whole lot to say about this because this is the one you are probably familiar with, because this is how software has been working since the late 80s. Definitely everybody was using it by like 1994 or 1995. So it's this is the one you're familiar with. The software doesn't just start at the beginning. Everything we've done so far is kind of put up a flow chart here, or a very stripped down flow chart. I should write that a little bit neater. That said do stuff. Right on the chalkboard, I forgot ASCII character 32. And then get to the end. Some sort of flowchart diagram for everything we've done so far, right? Maybe we had a loop, either a loop or tail recursion to keep the program running, get some menu-driven stuff. I'll write that. Menu-driven, either loop or tail recursion, whichever way, but something to keep it going, but it would just do the same stuff again, right? It didn't, would say run again and it'd go again. And there wasn't, it could be easily put into a flowchart is kind of the idea. But as you're probably well aware of, that's not how modern software really works, right? The software just sits there. We start it up, but then there's no arrow going to the stuff to do, right? We start it up, and then it just sits there and waits until the user clicks a button or starts typing on the keyboard. And it waits for the event to happen. We started it, the software just sits there and waits. It's what we're familiar with. Events can be anything. We're going to start off with some simple ones, the regular button clicks, left click, right click on the mouse, keyboard presses, basic ones on a computer, but anything that can happen is going to trigger an event. Or set up as an event trigger, and then that event trigger activates the software we want to run. So like timers and alarms, those are very common sensors. Let me grab one real quick. So yeah, just grab one. They were just right over here. So here's a ultrasonic rangefinder. Technical term, it's like a radar, right? It sends out a high-pitched sound wave that's going to bounce off something and come back and be detected. So we just set a sensor up like that to tell how far away things are, and then trigger use that to trigger our code to work. And that's an event, something that can happen. So lots and lots of, so any type of sensors are going to detect events. And that's a good way to think about it. So like your car, all those sensors that feed into the car's computer, those are all just sitting there listening for an event. That's the term we use, just waiting to detect the thing that sensor is programmed to detect. And then when that detection occurs, it activates a piece of software we want to run. And that's kind of what we do with event-driven code. We set up a listener, something for our mouse clicks and keyboard presses. We're just going to set up a listener for the to basically a sensor to listen, to wait and sense those events, mouse clicks or keyboard presses. And when it happens, then we'll create a handler to run the code. So that's kind of our two pieces. I guess a little background. The idea has been around for a long time. Obviously, there's the most basic form of input and output requires some sort of event to happen. So it's always been around, but with procedure-oriented programming, that's the stuff we've been doing that just kind of starts at the beginning and runs to the end. Does the same thing every time. It can be a bit of a beast in procedure-oriented programming. We want to at least modularize it, split it up into different functions. But once object-oriented programming took over, once computers could handle the inefficiencies in object-oriented stuff, event-driven programming very quickly became the name of the game. Or an example in my notes here, and it kind of relates to object-oriented and this stuff. Another way to visualize it is utensils in the kitchen. I probably should have put this example in the notes about object-oriented programming. But like utensils in the kitchen, right? They just sit there on the shelf or in a drawer until we're ready to cook with them. And they're all independent, right? Our 12-inch skillet and a spatula doesn't require anything from the 2-quart saucepan and a ladle in order to work. So kind of an object example, but I put the example in here kind of relating it to that. The stuff's just sitting on the shelf until we need it. So like those utensils are like the objects. They don't require other ones to act. So they just sit there on the shelf until we need them. And then the needing them is the listening. It's going to listen for that event of, well, with the kitchen example, is to reach up to the shelf and grab the skillet. But we'll need a listener. We'll set up a listener, which just is like a sensor. It just listens to detect when a particular event happens. A key press or a button click for us. And yeah, there wasn't a whole lot in these. A listener waits for an event to happen. Which is just a detect thing. To detect an event. I'll put the word sensor in parentheses. I like to use that because that's kind of what it is, but it's a virtual sensor. So a sensor kind of indicates the mechanical component that's sensing it. But a virtual sensor is what a listener is. And when that listener hears the event it's listening for, it'll call up a handler. We heard that word before with like file handlers. That's the thing that knows what to do. Yeah, basically, when listener detects event, the handler runs some code. So when we were talking about file handlers, I expressed that the handler is the thing that knows where the file is at, right? It's the thing that can see the file. Kind of same thing here. The handler is the thing that can see our methods. So when the listener detects a particular event, the handler decides which method will run from that event. And we'll be starting here. Most of our practice with graphical user interfaces and event-driven programming is going to be using the Visual Basic language put together in Visual Studio, which has a lot of no-code, low-code solution options in it. Particularly for the interface, we're going to use our mouse to drag stuff around. We're going to start here with typing one up using the TK interface package, which is one of the earliest interface packages that really took off nicely. It's available in almost every language. We sometimes have to import a language called TCL to work with it, but that's an extreme case. Most languages know about the TK interface package. It's kind of like an early model that other ones were based off of. And it's still in fairly common use. TK stood for somebody's name, if you're wondering about that. This is the guy that created it, the programmer that created it. I want to say Tom something. I should have looked it up before starting the video. It's easy to find. You can look up what it stands for, but it stood for his name. You know, that was his version of an interface package, and that's the one that really took off. And most of the ones that came afterwards were based off his model, even. So it's kind of like, even though if you never use it again after this class, it's like the grandfather of the one you will be using. So we're going to look at it in that. I'm going to draw a quick picture for what we're going to get into and hopefully help show some differences with one more diagram to show differences. Yeah, once we're in event-driven programming, a nice organized flowchart's not going to work anymore because we don't start at the beginning and go to the end. We start the program, sit there and wait for something to happen, and when that happens, it runs code and then sits there and waits more. So a nice organized flowchart doesn't really apply to event-driven programming. It applies, a whole bunch of flowcharts apply to it, but not an overall one. So I'm going to erase this and draw a picture, and then we'll do an example, and it's mostly examples. You should be kind of familiar with event-driven programming because that's what we do on computers. Personally, I would have started with event-driven programming and graphical user interfaces, or GUIs, because that's what we use. Nobody uses the console, but I need to be consistent. Like, I'm allowed academic freedom. I could set the class up that way, but I felt that it was kind of important to be consistent with all the other SDEV 140 courses running here at Sellersburg and all over the state of Indiana. I wanted to be kind of consistent with those, so then when you go to other classes, the other instructors will know what you covered in the SDEV 140 class. So that's why we didn't start with this. It's kind of, I'm not exactly happy about it being an afterthought almost, right? We do all this stuff, and then the way software that would actually be used is kind of thrown in as an afterthought rush through at the end. I don't completely agree with that, but I thought it was very important to be consistent with it. So let me erase this and draw a picture, and then we'll get into example, and it's pretty much going to be a whole example today, because I assume you're familiar with event-driven programming. Listeners and handlers. Oh, there was one other note. Let me pause the board and erase this. We're going to do this section of video down, and then I'll get to the other note, because it's kind of important too. While that first little segment of video was rendering down, I went ahead and checked, and as of mid-afternoon on April 13th, it's still on the Wikipedia page, so you can just check that. That's easy to find, but as you probably heard an English teacher or somebody say, you will find it more detailed in a more reliable source than Wikipedia, but I just checked a moment ago. The Wikipedia page still has up there, and that's usually really easy to find, right? Google always tries to make that our top concern. And the point is, criticisms with event-driven programming. It's kind of, nothing's perfect, so there are some problems. And a big one that I wanted to bring up, because it's highly addressed and it's only 3 or 4 pages. If you go to the Wikipedia page, scroll down, there's a section called criticism. Spells it out in like 3 or 4 sentences. But the criticisms are basically, this leads to code that is error-prone and overly complicated. So I wanted to mention that. Keep that in mind while you're working with this. It's going to require some extra debugging and refactoring. Debugging is fixing problems. Refactoring is cleaning it up, reorganizing it, making it look nice, just cleaning it up. So you're going to have a little bit of extra debugging and refactoring with this. You want to watch for that excessively complicated part. That's what that extra criteria I threw in the homework is about. I'll mention it. We'll talk about it more when we get over the screencast here in just a minute. But yeah, there's that special requirement I threw in the homework that I won't accept it if you copy the way the book did the examples. I'm just very, very displeased with that, and it relates to that overly complicated thing, so let's avoid that from the beginning is my thought on with that. Before we do that, I just wanted to sketch a quick use case to kind of compare to some of the earlier ones. Remember when we did the earlier use case, or I'm going to erase here in a second, we'd have an arrow coming in there, run our code, and an arrow coming back. And it just kind of flowed straight through the code there. Just like that flowchart point I mentioned a moment ago, or, up till now, our code, our programs, our software could be put in a nice organized flowchart where we had that start, run through all the blocks in the flowchart, and then hit the end. But the schematic for event-driven programs isn't going to necessarily be able to squeeze into one nice organized flowchart. In our example, we're just going to do a hello world to go over some of the syntax. And we're going to have 4 different events that we're going to listen for. So right off the bat, our earlier pictures, there'd be, 1 or 2, just a couple inputs, and they were all connected, right? We'd do the first input, then the second input, then the third input, then the fourth input. These aren't connected anymore. They're all one or the other, or all of them could happen, different inputs. What I was thinking is we'll do a right click. I didn't leave myself enough room, so I had to write R click. But a right click and a left click event, those are some kind of standard ones. And that's another thing, the way the book did it, we only have a left click, and it's a messy way to do it. The way the book did it, it's pretty much guaranteed that you have to write all your methods at least twice. So that's why I was like, I'm not going to accept that in the homework, so you have to do it by setting up actual listeners. That way we can do left clicks and right clicks, not just left clicks. We need some key presses as well. Control H and Control G. They'll give us 2 key presses. I might simplify that when we get over to the screencast and drop the control part and just do key press H, key press G. But right this moment, I'm thinking Control H and Control G. That's a little bit more standard, but I might simplify that when we get over there. I'll decide when I look at the code and see if I feel like it looks kind of complicated. And then, like I said, it's just a hello world. So then we'll have a method, 2 methods. One of them to say hi or hello world, and then we'll do a method to say bye. which is essentially just to have a second thing in there. Hello world and goodbye world. So a program, has a little bit more stuff in it, but there's some slight differences. Let's say our left click is going to call that method, which will send an output back to the user here in our use case. And our right click, try to avoid crossing lines, so I'll come way around this way. Our right click will call to say goodbye. So we'll left click to say hello world and right click to say goodbye world. So both of them independently send information out, right? So we don't have just one arrow coming back at the end. All right, we have two separate arrows, and depending on the situation, we're going to use one or the other. We might not need both of them. We might open the program and close it and not use either one. So it's not as definitive as the software was previously. And then I chose H and G. So like the Control H will run the say hi method, and Control G will run the say goodbye method, which is essentially just, I wanted to do at least two, because that's another thing. Right? We write the method once, and then give the users lots of ways to do that. That's kind of standard. You should be very familiar with that from using software, right? Lots and lots of different ways to do something, but we only need to write the method once, which is a problem with the way the textbook examples go. If we use that thing the textbook kept showing, it's a guarantee that we'd have to write every method at least twice, and it's way too restricted. So I was just like, for class, I'm just going to say that's a bad thing, and we're not going to use it at all. And then our user, well, our earlier flowcharts, we just drew a line coming from the user to this. But we don't know which one of these things the user's going to do. They could do any of them. I don't know if the colors will show up here, so I'm going to draw several different colors. So the green one, the user might right-click. The user might hit Control H. The user might hit Control G. Or the user might left-click. So you can see our use case diagram is a lot more complicated now. And it's not so definitive. We don't have one arrow coming in, go through everything, and one arrow coming back. Maybe none of these things happen. Maybe the user opens it up and be like, whoops, I clicked that by accident, and closes it back down. And then none of the in and out happens. Maybe some of it happens, maybe all of it happens, but you can kind of see the more complicated flow of things here. So those flowcharts don't really represent our program so well anymore. So when we get into what's some other ones we've seen? State transition diagrams. Our state transition diagram isn't going to be a flow from a start to an end, right? We're going to have an overall one, and then it's going to hit a section where it's listening for events, and then we're going to have a whole bunch of subcharts showing those state transitions depending on the event. So slightly more complicated flow, but hopefully that makes sense and helps to show some of the differences while still consolidating all the information about what our program is going to do into a diagram. So that's the plan. Let's go over to screencast, and I assume everybody's familiar with event-driven programming. That's what we do when we use computers in modern times. For longer than a lot of y'all in the class have been alive. A couple of you guys might remember using computers a long time ago when we actually used the console, but it's been it's been standard to have it event-driven for a long time. So that's kind of the way you should be familiar with. So we're going to jump over here, do this example real quick, and then I'll let y'all run with it and practice just that requirement, which we're going to cover in the screencast. So you'll see the difference, and I'll try to explain why we're doing it, why it's better than the method the book shows, why I didn't even want to accept things with the way the book does it. I mentioned in the intro, I've never found a textbook I'm happy with event-driven programming stuff for. It's very disappointing. I guess I should write my own textbook to introduce the stuff, because I've never found one I'm even remotely happy with the way the textbook introduces event-driven stuff and graphical user interfaces, which is the standard we're going to use. So let's go put one together, and then I'll let y'all run with it. And your software is going to start to seem like something that's like more like real software, basically. So let's go get started on that. Okay, so now an actual example. I went over that thing at the beginning, just some things that I wanted you to think about moving forward. Kind of where the goal of what you're looking for with GUIs. Obviously not going to be there in the first day. It takes a minute to build up to that. There's a lot going on. But as we get into this example, there was the note in the homework assignment where I pointed out that in the homework assignment I requested that you not use the command attribute built into the GUI components in tkinter. The reason for that, it relates to that criticism issue we were talking about, with code being overly complex. If you use the command attribute, it guarantees that you'll have to write 2 versions of every method. And that kind of overly complicates things. We want to write the method once and then have a bunch of ways to call that method. So that's why we want to use actual bindings. So I'll include that here, how to use those, and a couple small points to get started. Not getting too far into this, nowhere near that example we started with, but just to kind of get started. And like I mentioned, I was very unhappy with the way the textbook presented this, to the point that, if you copy the textbook examples, stated I'm not going to accept the assignment, because that is very, very bad form for writing your code, for setting up your listeners and handlers. And limited. It's very restricted. You can't work with every listener and that way, which that's where it brings in the pretty much guarantee that you'll have to write 2 versions of all your methods. And it's back to that big criticism of overly complex, which we want to try and avoid. It's obviously a complex thing, but we don't want to go overly complex with it. So we need to import our package, the TK interface package. Most people just read tkinter. I've heard some people just say knitter. Different ways to pronounce it. But it's TK interface package. It's one of the originals. I don't need an equal sign there. I don't know why I was typing that. One of the originals, and it's available in almost any language. Some of them we still have to work with a language called TCL and bring that in. But in Python, it's fully integrated, so we can do everything in the TK interface package directly in Python. So I'm going to import that with the name TK. And I mentioned there's an updated one that looks a little bit better. I'm going to work with the original one, but I want to at least preview something on that. So I'm also going to bring in tkinter.ttk as ttk. So remember, if we do the as, we can just refer to it this way. So instead of tkinter.button, we can put tk.button or ttk.button for the better looking one. Let's see, as I come down here, I'm going to do this procedurally rather than object-oriented. So that means the methods need to be at the top, since we're working in an interpreted language. Come back and do those last. And then I'll come down here and set up a section where the actual GUI is going to be. Now to initialize our GUI, I'm just going to call it that. I'm going to call it GUI. Oh wait, I should follow the naming conventions this week. I almost forgot about that. I'm not going to call it GUI. I'll come up here and make a note about our weekly naming convention. I just remembered I skipped doing that in the previous video because I was worried about confusing myself while talking. What is our weekly naming convention? Weekly notation is Pascal case. All right, guys, one word. Pascal case, at least 3 words long. And the 3 words long is to make sure it's in Pascal. So you can tell for certain it's in Pascal case or camel case or juxtaposition. It's kind of hard to tell with just one word isn't quite enough. So I need 3 words. My example GUI, that's 3 words long, and in Pascal case. Oh, actually, why don't I spell it out? Graphical user interface. Instead of saying GUI, I'll just spell the whole thing out. Now to initialize these, we call that TK module we imported, and then .tk with a capital T. So that's the object itself that is in that module. So tk.tk sets up our GUI. And, well, actually that'll run. So I'm going to come down here, graphical user interface, Pascal case. So it's just like camel case, each subsequent word is capitalized, but Pascal case also has the first letter is uppercase. I save that. Come down to the flash drive. Hello example. Let's call it hello example. If we run this, you see that already is enough to start a window. Has this little icon. I made a point about changing that. Not a big deal. And by default, our regular close, maximize, minimize buttons, a bit of space, but that TK is what we need. The TK object is what we need to create the interface. Obviously, we need to put some stuff in there. So I'm going to start with the interface itself. So our object graphical user interface .title. We'll probably put some words on there. I'll call it Hello GUI World. We're just going to do a very simple Hello World. Well, I wanted to do a couple things. We'll do Hello World and Goodbye World. That way we can set up different bindings. And one I think is a good idea to go ahead and set every time is the size. So that's a geometry. So whatever the reference name is, then .geometry sets up the size. And we have this kind of standard geometry objects we pass in as a string. I'll just do 500 by 300. And that can be a really good idea because without specifying the size, it might be different on different runs or different people's machines. So you probably want to take control over how big it initially opens to. So save that and run that. You see it just gave us this size that's 500 pixels by 300 pixels. I'll put a title up here. You probably want to do those things every time. Just for having control over it, and labels are important. It's kind of the thought between those. But now we need to put some stuff in here. I'll call this send message button. So that's Pascal case, 3 words long, and each one starts with a capital letter. Or you can think of it as just like camel case, except the first letter is capitalized as well. Now to create that, we're going to ask for that TK module, and there's something in there called button. And the first argument cannot be left off. The rest of them are optional or can be done later, but the first argument we send has to be there, and that is where are we going to put it. So as things get more advanced, you're probably going to set up some like empty frames and organize things in there. I'm going to start by just putting it in that graphical user interface. And I'm going to go ahead and put some text in there. Text equals, I don't know, click me. And to put that into our graphical user interface, there's different ways we can pack it in, or pack it in just loads it from top to bottom. It puts the thing at the top, the next thing, then the next thing, then the next thing. Or we can use .grid where we give the row and column number for it. For this example, I'm just going to start by packing it in. So I'll ask for that button, message, button dot pack, and that just put it in there. And that, if we do just dot pack, that just loads from top to bottom. We can anchor it to different places: the left, the right, top to bottom. A lot of the syntax in the book is okay. There were just some things I was very, very displeased with, and one of them is going to be the command attribute in this button. That's the one that the instructions in the homework are like, please do not use that. I'm just going to add a couple attributes, so pad X, so some X padding, which I'm doing by default, so it's going to center everything, so the X padding is not really going to matter, but pad Y equals, let's do 30 pixels of padding X and Y position. So hit Control S to save that. Now F5 to run it. You can see it put our button in here with a little bit of padding. Spaced it out. Yes, now we have a window with a button in it. It finally feels like we're getting somewhere, right? Have the appearance of a GUI, and yeah, like I've mentioned before, I would have started with GUIs because, well, nobody uses the command prompt. We stopped doing that back in the mid-'80s, 35 years ago. But now we have something that looks right. I would have liked to started with this. One thought I've had before is, lesson 1, just kind of lecture 1, day 1 of these programming classes, start out and make a text editor and then be like, okay, now you have to use this text editor to write all your code until you can make something different. That's probably way too extreme, but start with GUIs, the ones we'll actually be using. That way it's not like here, it's kind of thrown in as an afterthought, but I need to be consistent with how this class is taught, all the different versions of this class taught at all the Ivy Tech campuses. So we'll go with just throwing a GUI in as an afterthought, but I feel very strongly that should probably have been the first thing we did. But so exciting, we're finally getting something, regular window like we would use, and this button, but then that's the point of the other module I brought in there. This button, it doesn't do anything yet, but that kind of looks a little outdated, right? We can restyle it and do some other stuff, but that kind of looks like it belongs back in the 90s or something. So that's what that other package is. So I just brought that in to kind of show the example. I have a feeling you'll probably want to work with this tkinter.ttk package instead of the tk. I'm just going to throw one on here just for an example, but I am going to work with the original right now. All the stuff we're going to talk about here will work in either one. So ttk.button. And again, we're going to put it in the graphical user interface and some text on it. Better looking button. And then I'll come down here and just pad that in right next to it. Better looking button. Notating things in Pascal case this week. Then we have this .pack method, which by default throws it to the center of the thing. Just out of habit, I'm going to go ahead and write the X padding. The Y padding will do a little bit more or less, but 20 pixels of padding around that. So Control S to save it, and F5 to run it. Uh-oh. Whoops, I forgot my assignment operator. Better looking button is assigned an instance of the TTK button. That's kind of important. So save that, then F5. I forgot it there too. Wow. Was I just not reading what was on the screen? Sorry about that. But yes, we need the assignment operator. That's kind of important in programming. Oh, I'm using the wireless keyboard. I bet my batteries are going down. Next time I pause the video, I will change those out. Okay, ran that time. So you can see our button still don't do anything, but a slightly more modern looking button. There's still some styling we can go with, but well, you can see right off the bat, it has the normal hover behavior on a button. Looks a little more modern than this one, just by default. So you might want to work with those just because they look better. I'll go ahead and leave that on there, but I'm going to work with this original one. The same concepts will apply for the other one. So finishing out our components, we're just making, well, like the name implies, for example, we're just doing a hello world, so we need some place to put this stuff. I'll add comments afterwards, like normal. So we need a label. So I don't know, my output label, 3 words long in Pascal case. I'll just use everything else. I'm just going to do the original TK. I just wanted to point you towards that other package somewhere because it looks a lot better. And again, the first argument has to be passed in, and that is what we're putting it in. So here I'm just loading them into the window itself. But in most situations, you're probably going to want to create a frame object and then load them into the frame, but that would be exactly the same. So like my frame equals tk.frame, load it in the graphical, in the GUI, and then the button and label would be loaded into the frame instead of directly into the GUI. Hopefully that extension is extending to that's kind of easy. I wanted to keep the example as simple as possible. And I'm going to start by just having the label blank. I'm going to come down here and pack it in. My output label dot pack pad X, so just do 10 pixels of that, and pad Y, the one that's actually going to show up here, I'll put like 50 pixels. Right? How many is that? 30, and that'll be on both sides. So 60 plus 40 is 100 plus 50, so we're still well under the 300 height for the screen. It's 500 wide in the X, 300 pixels tall in the Y. You might want to watch for that and pick this number based off how much space you leave around your things. Control S, F5, it's not going to show anything just yet. Uh-oh, got an error. A typo. And to show it, I'm going to put like a test word in there. I left a T out here. My output level. There we go. So it's going to have a label down here to put a message. So we'll click a button and a message is going to show up here. And then we'll also do a key press that will do the same thing. And that way we have demonstrate that core concept I've mentioned, that we want to write our methods once and just have a bunch of ways to call them. So I guess the next thing, probably write our two methods, and that way we're ready to call them, and then we'll set up our listeners. So we've seen writing methods before. So define, say hi, and we want to pass in an event. And this is where the problem with that command attribute and the button shows up. Because if we use the command attribute, it does not pass in an event, which causes problems if we want to have a keyboard press do the same thing, because the keyboard will always pass in an event, and we need two different methods. So I'm just going to do a normal binding on the button, the same as we would bind any listener to this event. Any event listener, we can bind them all the same with this other syntax, and we don't have to pick and choose. That's another thing. It's what we're going to look at here. That extra requirement in the homework that's not mentioned in the book is the one that will work everywhere, not just in a few places. So this, we will need to change that output label. Output, I'll go ahead and type it, and then, whoops, text is going to be reassigned just the standard hello world. And notice I didn't call that output. My output label has, well, we saw a list. But notice how this is being indexed. We're indexing it by a word, not a number. So this label we created down here, we're going to refer to that, and just like a list, it has a bunch of elements we can refer to in it. All of these attributes that we assign. So far we've only seen the text one, which that test was okay, so I'm going to start off with the blank label. But all of those attributes that we would fill out here when we create it, we can access as a list, and instead of indexing it by numbers, we'll index it by words, which is a whole lot easier to work with. And that's called an associative array, is the term for that. Associative array, where we index things by words instead of numbers. So much easier to work with. Might as well set up the say by method. And again, we're going to pass in an event because our listeners will hear the event happen, and and then pass information about the event. So not so much on button clicks, but on key presses. If we press the T key, the event is the listener detects that the T key was pressed, and then it passes in information about that press. how long did the press happen? Was it held down? Was it released? Different thing, different information. Or with the keyboard, which key was pressed is kind of an important one. Then we can run an if block to figure out what to do on different keys for the method. But in this simple example, we're just going to go to that output label and change the text attribute of it to either say hello world or goodbye world. Now we need to call those two methods. So let's set up ways to call those two methods, and this is the particular thing. It'll be the way we're going to bind our button to a listener and handler is the one that will work everywhere. So we'll see it, let's do a right click. A right click on our button to say goodbye, and a left click on our button to say hi. And then we'll add in a couple key presses. G and H seem like good keys for that. So we'll do like Control G to say goodbye and Control H to say hi. So let's set up those listeners. Oh, whoops. Let's not move on just yet. Right off the bat, and then follow the naming convention on those. Say hi. Well, it's in camel case, not Pascal case, and it's not 3 words long. So let's call this just saying hi. There we go. That's 3 words. And in Pascal case, that's all, folks. There we go. That follows the naming conventions. So kind of means the same as say hi, say bye. But following the naming conventions. Oh, where I just left my mouse hovering. I said that applies everywhere. One example might not really show that. Let's do at least 2. So what else can we do? Oh, the button. I'll make that button blue. So BG equals blue. So I'll give it a background color. So our send message button should be blue when we run it. If I save that and hit F5, and now we have a blue button. So let's change the color of that in our methods as well. And we can do the same way in just a second example on the associative array deal. Where'd my cursor go? There it is. So we called that send message button, and then we can access any of the attributes as if they were part of a list as an associative array. So we have that attribute in there called BG for background color. So let's assign that a couple simple colors. We put it green when we say hi, and then we'll turn it red when we say bye. Send message button, the BG attribute of that component or widget, whichever terminology you like. But the component, the TK component here, any of them, we can access all these attributes about them. We can access through an associative array. Now there's at least 2 examples showing that, and I remember to follow the case, follow the naming case. You mentioned Pascal case. That's what I was trying to say. Remember to put it in Pascal case, which is the requirement for this week. So now we need to call that method. So let's do the button first. I'll put that down here right underneath the buttons. And this is the one, that extra thing on the assignment that the book doesn't show. This is how we bind it, how we set up any listeners and handlers, not just a short list of them, like the book shows. So we have that send message button, and then on any component of the GUI itself, we'll see that one in a moment, or anything we put on there, we can do .bind, and then we'll pass in two things, a listener and a handler. So it's not very complicated. And in TK, the TK package, our listener goes in as a string, and then we'll call the handlers just which method to call. And the strings always kind of look like this. I've mentioned that the TK interface package is available in almost every programming language. So anytime no matter which programming language we're working with it in, the listeners will always have angle brackets. And inside of those angle brackets is what we're listening for. So let's say button 1, and that's our left click. So on our left click, we want to call that just saying hi method. And the examples in the book, up here in the button, they put one of the attributes, they put command equals just saying hi. So you can see it's not necessarily more complicated. The only thing is we're specifying which button, the left click button. That command one only handles the default, right? Only handles a left click on that button. And we might want to do more than that. And then the big issue is the command does not pass in events. If we just do a regular listener handler binding, it will pass in information about the event. It'll say which button was clicked to call the event, how long it was clicked. There's a bunch of information we can get to, the XY coordinates of where it was clicked, and other information we can use in more complicated situations. But there's a whole lot of information about the event we might want to use. So that's why this way is this is a much better way to do it, because then we have the information about that click. It's not just a simple default click. And this will work for all of them, because we can set up the second one, our send message button. We can have more than one event. So we'll set up our listener here as a string, and this time let's listen for button 3. So button 1 is the left button. Button 2 is the scroll wheel. Those are usually clickable, so that's clicking the scroll wheel. And button 3 is the right click. So when we right click on the button, then we'll call the message, that's all folks. Whoops, I'll call the method, that's all folks. And hit Control S. And that's the one for your homework. So instead of command equals just saying hi in your homework, I put in the requirement to do it this way. Use bind a normal listener handler. Bind listeners and handlers in the normal fashion. The better fashion, where we have information about the event. And we don't have to write different methods. If we use that one, we could do command equals just saying hi, but then we don't have any way to right click as an attribute. And if we wanted to have another one call this, like say keyboard press, which we'll do in a moment, the keyboard press does have to have an event. So then we'd have to write two almost identical methods in order to use that command attribute. So that's why I was asking, please don't use that in the homework. I believe I put a note in there that I won't accept it, which I think most of y'all know that means you'll get an email from me asking you to redo it. I usually try to put details in the emails. I don't just say redo it. It'll say, please resubmit that, and have an example showing what I want you to put in there. But I feel it's important to do it this way, not with that one the book uses. So let's run that. Control S and then F5. So it still looks the same, but if I come up here and left click on the button, oh, it turned green and threw up the message. threw up our hello world message. And if I right click on the button, it turned red and called goodbye world. So right off the bat, you can see there's two things we can do with that button already with this method that I want you to do. Let's go ahead and bind and do the key press binding. So close out of this, close out of this, and for our key press, I like to bind the key presses to the window itself. There's probably other ways. Graphical user interface. The GUI itself, our overall window, right? The one we set up and then we call the main loop for. Which I put down here, that's supposed to be .main loop. Yeah, that works. There should be a .main loop at the end. I just kind of forgot to put that in, but if it's the very last line of code, that will be okay. I'll go ahead and type it in. Because it's only okay if it's the very last line of code. We can just say our object and then the .main loop is implied, but it's better to go ahead and spell it out. Sorry, back to the bindings. So the window itself, the one we're calling the main loop for. And our bindings, well, once again, it's just .bind, and then we'll pass in a string for the listener, and then for the handler, we just pass in the method that we want to call. So our string here is going to look the same. So inside of angle brackets, we'll say what we want to put. So let's do key press -H. And the lowercase is important. Notice I didn't put shift key press capital H. So if you want to use the shift key, make sure you use the capital H. If it's a lowercase h, make sure and type lowercase h. We could also do Control-H. I'm just going to do when we press an H key, try to keep this simple. When we press an H key, it calls that method just saying hi. And then another one. So on the window itself, we're going to bind that to key press G. That seems like a good one. Hello and goodbye. And when the G key is pressed, we'll call the that's all folks method. And that's all it takes to set up our binding. So now that event will bring in information. Like it'll have the press for an H brought in so that we'll know an H key is what called this. Or a button 1 on the send message button is what called this. So we have that information. So save that, run that. So you can't really see my keyboard, but if I press G, you can see the button turned red and says goodbye. And if I push H, you'll get hello world and the button turned green. If I come up here and right click, you get the goodbye and the red. Left click, get the hello world and the green. And that's a couple key concepts. So that's going to kind of wrap up this example, this short example. The big thing there is please do your bindings this way. I definitely put that requirement in. I feel it's very, very important. Using that attribute strips a lot of things away and makes it more complicated. And like if we tried to do that from a left click button and a key press, we would have to write two methods to do it. One that took an event and one that does not take in an event, which makes it overly complicated. And back to that common criticism about event-driven programming that we looked at earlier. So the bindings, you can see it's fairly easy to write, just .bind. the event we're listening for, the method we want to call. And here's our setup, how we set these up, and any of our attributes for our widgets showing on the window, we can access those via an associative array. Hopefully that example is enough to get you started. Most of the GUI stuff we're doing in class, we're going to be doing on Visual Basic, which is a whole lot easier. In Visual Studio with the Visual Basic language, so no code, low code solution, we'll be dragging the mouse around to put the GUIs together. Starting out with typing here, and I would recommend you get more practice than this than the Visual Studio one as time allows. I know that's hard to find time, but I'll add some comments in and send this out. And next week we'll be taking a look at GitHub and a couple other odds and ends before we get into the Visual Studio stuff.